Friends, just a few days ago, a Singapore Airlines flight number SQ321 was flying over Myanmar. It was flying from London to Singapore, and suddenly it fell about 200 feet in a matter of just 4 seconds. Imagine 200 feet is about 20-storied building, and within a matter of 4 seconds it dropped like a stone. Now what would have happened inside? The people who would have been not strapped to their seats would have just become airborne, and they would have hit the ceiling of the aircraft. It was a large Boeing 777 aircraft, and people along with the other cutleries and the trolleys, everything would have become airborne, and the scene would have been very chaotic. After 4 seconds, the aircraft recovered, and all of that would have fallen back to the ground. A very bad situation indeed. In this accident, one person tragically lost his life, and many were injured. The aircraft was a very large aircraft. It was carrying around 211 passengers and around 18 crew members. Now in this video, we are going to talk about the air turbulence, and particularly the clear air turbulence, which most probably was the cause for such an event. Whenever we fly, we do encounter bumpy rides at times, but what really happens, what is the mechanism in the weather which causes all these bumpy rides to happen is not very clear. So I thought I'll make a video to make this clear to the public at large. But whenever the aircraft encounters a region where different parts of the air it is encountering are going chaotically in different directions, so that is what is called unpredictable motion of the air, movement of the air, which causes turbulence. It causes aircraft to shake violently and sometimes drop by a large amount. Now generally people associate air turbulence only with the stormy weather. Well, that is not correct, because air turbulence, violent air turbulence, can occur in the absence of storms. It can occur in the very clear air, and since there are no clouds, you don't get any clue whether the clear air turbulence is going to occur. Now, clear air turbulence can happen due to variety of reasons, but most important reason for this is wind shear that happens in the vicinity of jet streams. There are other reasons also which can cause CAT, that is mountain waves, the thermal and convective wind shear, and the ground friction also causes turbulence in the air, which can affect aircrafts, but not so much. Now if we look very closely at the Earth-Sun geometry, we can clearly see that the sunlight falls nearly perpendicularly over the regions which are close to equator, and as we move far away from the equator, the solar radiation received by the regions is less due to its angle. So due to this differential reading, essentially what happens is that the water from the oceans which are there near the equator evaporates, and the warm air rises, and it has the tendency to move towards the poles, and the cold air at the poles has the tendency to come towards the equator, so it causes an air circulation. Now if the earth was not tilted and it was not rotating, this circulation would be very straightforward. The movement would be very simple from the equator to the pole. But due to rotation of the earth, what happens? The air, when it travels from the equator towards the pole, it starts bending towards right, and the movement becomes west to east. I mean, this is called Coriolis force effect, and you can refer to my video on a cyclone, earlier video, to understand what is Coriolis force and how it bends the air. So air, when it moves in northern hemisphere, it again turns right, and when movement is in the southern hemisphere, again it turns right. So the movement is always west to east. Now the land area on the globe is not uniformly distributed. The oceans are also due to this different in different regions. So due to this non-uniformity and the Earth's rotation, what happens is that in each hemisphere, 3 circulation cells form. We can look at the slide, and these circulation regions, the airs are confined to these cells. So when the air movement tries to happen from the equator towards the poles, it bends right. It wants to go towards east. Now what happens? It gets confined to the cell boundaries. It can only travel at the cell boundaries, and there are since 2 cell boundaries, so 2 distinct bands are formed in the northern hemisphere, and similarly 2 distinct bands of air are formed in the southern hemisphere. These are bands, or these are rivers of air, which are called jet streams. These jet streams are nothing but narrow bands of air currents which flow with very high velocities. The highest velocity may approach as much as 450 kilometers near its core. So these air currents, they flow from west to east with an average velocity of around 200 kilometers, and they are known to occur between 5 and 12 kilometers height. Now they can be few hundreds of kilometers wide, but their thickness is limited to few hundred meters. Now these are bands, we can also call them strips because their thickness is limited. They can flow in one stream, and they can also break up into many smaller streams. Now what happens if they break up and on top of that they do not flow in a straight line? They are wavy in nature, and their location also goes on shifting because as the sun moves around the equator due to tilt of the earth and its rotation, these jet streams tend to follow the sun movement. So their very location becomes little bit unpredictable, and an aircraft might encounter one of the strips in an unexpected way. Now imagine, they are like rivers of air flowing at very high velocity, and if we talk about, say, a river of water, near its bank where water hits the bank, the movement of the water is very chaotic. The same thing happens to the air. When the jet stream boundary hits the surrounding air, which is not moving at such velocities, the various eddies are created which go in a chaotic way, and if aircraft happens to enter that region, it can be really tossed around, and it can even drop hundreds of feet in a very short span of time, and that is what happened. Furthermore, these jet streams are responsible for carrying weather. Since they have high velocity, they can push the weather systems, and the weather systems get transported from one location to the other through the jet streams. Now imagine if a weather system gets coupled to a jet stream, the situation becomes all the more violent and crazy, and it can be a very difficult situation for an aircraft. But modern aircraft, with their communications, the pilots which encounter who encounter turbulence, they also communicate to other pilots as to the location of the turbulence, so that other pilots can go around it and escape it. There is a particular way the aircrafts have to enter the jet stream and take advantage of the stream as they fly. Sometimes it can aid their velocity and reduce the travel time, but there is a particular way how to enter the jet streams. But if an aircraft encounters it unexpectedly and enters the region which is very chaotic and having great amount of wind shear, then definitely the aircraft suffers, the passengers also suffer. Well friends, in this video we have learnt a little bit about global air circulation patterns. We have learned a bit about what are jet streams. We have learned how the clear air turbulence is produced in the atmosphere. We have learned how it can affect the aircrafts. We have also learned different causes which create clear air turbulence in the air. In our next video, we will learn more about these mechanisms in detail. So till then, goodbye.